Reflections of functions. We know that the general rule for reflections is if we're going over the x-axis, it's the opposite of the y value. If we're going over the y-axis, it's the opposite of the x value. Let's talk about how to do that in rewriting functions to be able to go over a line of reflection. The original function we're starting with is being multiplied by a -9. Anytime we want to go over the x-axis to change the y values, we have to account for two things. We have to account for vertical movement from the line of reflection, which would be a translation, and we also have to account for the values to be able to flip it into its opposite direction. So a -9 would be changed to a +9. This would make everything go upward. We know that from the original function, it was translated 8 units up from the line of reflection. That means we're going to go translate it 8 units down from the line of reflection. You can see in the original function, we are taking all of the x values and multiplying by a -2. To take the opposite of that, we need to multiply by a +2. You can see that the translation was moved downward, so we would have a y-intercept of -1. If we go over the x-axis to the opposite direction, it would have to be above the line of reflection by +1. Over the x-axis, you can see that the function is being multiplied by a +7. To take the opposite, we'd be multiplying it by a -7. You can see that the vertical movement above the line of reflection, or the x-axis, would be up 5. To take the opposite of that, it would need to be below the line of reflection, 5. You can see here that the function is being multiplied by 10, so that means we would multiply it by -10. We also know that it's going to be flipping it in the opposite direction, so that means that the translation of it being shifted up 8 units from the line of reflection, now it must be shifted down 8 units from the line of reflection. What about going over the y-axis? Well, the y-axis is going to just be the opposite of whatever our x values were. So it's moving side-to-side movement, so we're not going to have to account for any vertical movement. That's why you're just able to take the opposite of whatever's being multiplied. Reflection over the y-axis is pretty simple. This one's confusing because this is an absolute value function. Whenever we're talking about reflecting an absolute value function that has not shifted horizontally, it's going to already be on the y-axis and it will be symmetrical. So if you wanted to reflect an absolute value function over the y-axis that has not been shifted horizontally, it already is a reflection of itself. That's why those remain the same. You can see that whenever we have stuff tied to x, so that would be a shift of right 10, we want to go over the y-axis, that would be a shift of left 10. You can see how it's starting to take the opposite of whatever was happening for the vertical movement with a reflection over the x-axis. You can see here that the x values are being shifted right by 2, and these are going to be shifted left by 2. So those are the same amount of shifts in direction of the function from the line of reflection, aka the y-axis. Let's take a look at some of these practice problems and see if we can rewrite these equations. So we know a reflection across the x-axis, that if we wrote g of x, we know a reflection over the x-axis is going to be the opposite of what is being multiplied and the opposite of the vertical shift. So that would be 4 times x minus 5 minus 8. Across the x-axis, we know that's going to be the opposite of what's being multiplied. We know it's going to be the opposite of the vertical shift. So g of x is going to be 4x plus 4. And you can plot these and check them. You'll see that they are reflections over each other, and once you do this enough times, you'll start to see the pattern. X-axis is going to be opposite of what's being multiplied by and the opposite of the vertical shift. So g of x equals -3, x minus 1 squared, plus 3. Now to go over the y-axis. We know that over the y-axis, there's not going to be any change in vertical shift, so all we're doing is manipulating the opposite of the x, which is going to be right here. Take the opposite of that, positive 10 plus 3. So vertically it stays the same, but it does shift to the other side of the or the y-axis. Okay, reflection over the y-axis. You can see that it's going to be taking the opposite of every single thing in the function. So what this is going to do is g of x is going to be 10, and it's going to be a shift of not -9 horizontally, but x plus 9 horizontally. And we know that there is nothing changing with the vertical movement. So this didn't change because it's not manipulating the x values. Anytime we want to go across the y-axis, we're talking about an equidistant shift in where those values are x-wise, so horizontally. -9 is going to stay the same over the y-axis, but we do know that we're going to be taking a horizontal shift the opposite direction. So g of x equals -9 x plus 4 squared minus 9. So you can see that that change to being equidistant from the y-axis, being shifted to the right 4 is now being shifted to the left 4.